Hi, welcome to Lesson 21A, Correlation. The goal for today's lesson is to become familiar with the terminology of and working with correlations of data. So a correlation refers to the relationship between two variables. We can talk about the height of a tree compared to the amount of rainfall. We can talk about the distance somebody jumps in relation to their height. We can talk about perhaps or show a graph of the number of baskets sunk in relation to the distance from the basketball hoop, etc. So there's all kinds of relationships that we can graph. And so today we're going to be talking about the correlation between those variables. So the first thing that we're going to look at is we're going to look at the direction. So when we have a scatter plot where it looks like the trend is going upwards, up to the right, then that description would be positive. Now there's a few more details to that, but we'll look at those in a little bit. When it's a positive relationship, that means that the dependent variable is increasing as the independent variable is also increasing. When we look at a general downward trend, downward to the right, we call it a negative relationship or a negative correlation. And that tells us that as the dependent variable, the dependent variable is decreasing as the independent variable is increasing. Okay, so we might want to make note of that. And now this one is basically no correlation. I'd like to see a few more points in here to make it look like there's no way that you could actually draw any kind of line or curve through it to make it to show some sort of general trend. So in this case there would be no correlation because it's hard to know is the dependent variable increasing as the independent variable increases, or is that dependent variable decreasing as the independent variable increases, or is there no relationship between the two? Okay, so in this case, there's no relationship. Then we move on to what's called linearity, and linearity is what we try to look at the data points, the scatter plot, to see would it form, or would the general trend that we could draw, the best fit line or the trend line, could we form a line with that through it, or would it be a curve? Okay, so these points you can sort of see that they would be approximately linear, and for these ones you could form, now the line's already there, but you could see that there is a bit of a curve. So they do not follow a linear trend, but it's more of a curve. Okay, that could be like a curve of best fit. Now here's, in this line here that you'll see, it says we determine whether the points are linear, follow a linear trend or not. In other words, they approximately form a straight line. Well, that's kind of redundant, because in math, if we're talking about a line, it's going to be straight. So mathematically, at least, if you're ever talking about anything linear or saying it's a line, we know by default, because it's mathematical, that it's going to be straight. So this is redundant to say a straight line. So it's either a line or it's a curve. Okay, so you don't have to use straight line. Okay, so now let's move along to strength. So we've looked at the direction, positive, negative, and correlation, and then there's of course different strengths too. So when we look here, we see that we've got different strengths. So if the points are clustered very, very closely around that line, then we say it's strong. So we can say that would be strong positive correlation. When the points are a little bit wider, a little bit spaced further apart from that line, we call it a moderate positive correlation. And then if the points are even further away from the line, from the general trend, the trend line, then we call it weak positive. And then the same thing goes for negative. You know, that's negative, not because the points aren't very close, but negative because the dependent variable is decreasing as the independent variable increases. And because the points are very close to each other, close to the trend line, then we know that's a strong negative correlation. This would be moderate correlation, moderate negative, because the points are scattered a little bit further away from the trend line. And this is weak negative correlation because those points are further still from that trend line. And then we get into what's called outliers. Well, we've talked about outliers a fair amount so far. And basically an outlier is what they call an isolated point that is away from the general group of data. So here's an example where here's an outlier. Well, you might think it is an outlier, but because it follows the trend of the data, it's in line along that trend line, then we would not call it an outlier. If it's away this way, further away from this cluster of points, further away from the general trend, then we would call that one an outlier. Okay, so again, outliers, if they've been collected and recorded and graphed correctly and properly with no error, then they're not outliers. They're not, they're still outliers, but they're not discarded. We still have to take account for them. If there's been some sort of error in recording or collecting of data or graphing, then we discard the outlier. Okay, but only if there's been some kind of error. And then we look at causation. There are causal relationships, and causal relationships would be, just as it may suggest, one variable causes a change in the other variable. So that would be a causal relationship. Not, as people may think, casual. It's not a casual relationship. It's causal, where the U is before the S. Anyway, so could you take a look at the two examples of causal relationships on page 548? And there's just a little description of running races and age, etc. And in the text, the authors relate the running speed to arm length, and they discuss that part of age. But what I'd like you to do is really take a moment to think about that. And is it really the age that determines the running speed? Could there be something else, some other sort of variable that would be related to arm length that would determine running speed, or that would cause an increase or decrease in running speed? Okay, so think about that for a minute, and then we'll discuss that tomorrow. Okay, and then in the meantime, we've got some practice questions for you, page 549 to 550, numbers 1 to 4. Take a look at some of those. This is a very short section. You don't, like I said, you don't have to do anything tonight necessarily besides this video, and do a little bit of thinking about the causation and the causal relationships. We'll answer some questions tomorrow in class, and we'll let you work on your practice in class tomorrow. And besides that, thanks for watching, and we'll see you in class.